Here we look at using the mean and standard deviation in some cases when we're talking about the binomial distribution. Right, these will be helpful formulas. Now these are specific to the binomial distribution. These look a little simpler than the formulas we were using earlier for just generic distributions, generic discrete distributions. These are specific to a binomial distribution. And yeah, so the mean will just be n times p, remember n being the number of trials, times p, the probability of success. And the variance will be n times p times q. In other words, the number of trials times the probability of success, and then q times the probability of failure. Remember, q is also the same as 1 minus p. And then the formula for the standard deviation, of course, would just be the square root of the variance. And our round-off rule, in this case, will be just to the nearest tenth, in other words, 1 decimal place. And here, let's look at this example. According to the U.S. Office of Adolescent Health, nearly 90% of adult smokers in America started smoking before turning 18 years old. If 300 adult smokers are randomly selected, how many would we expect to have started smoking before turning 18 years old? Okay. So in this case, we're computing our mean value. Remember, our mean value is, sometimes it's called our expected value, so we can also interchange between expected value or expectation and the mean. So when we say how many would we expect to have, then we're computing the mean. And here the mean again is just n times p, the number of people in our survey. Let's see, we had 300 adult smokers are in our survey, so that'll be n. And our probability that they were smokers would be 90%, so we'll do 0.90 for p. So our mean will be 300 times 0.90, which is 270. Part B, would it be unusual, in this case significantly high or significantly low, to observe 240 smokers who started smoking before turning 18 years old in a random sample of 300 adult smokers? And what does this suggest about the population that we observed? And let's take a moment to remember, what does it mean to say significantly high or significantly low? That means generally that we're more than 2 standard deviations from the mean. In other words, 2 sigmas away from the mean. In this case, the mu that we computed earlier. Now 240 is less than 270, so we can see, okay, when we compute the mean minus 2 times sigma, that'll tell us sort of what range of values is going to be considered significantly low. So anything less than this is significantly low. We'll see if 240 is significantly low. So let's see, in this case, the mu that we got was 270 minus 2 times sigma. Let's compute the sigma really quick. So sigma was our standard deviation. So here I'll compute that over here. It's the square root of n times p times q. So n was 300, p was 0.90, and q, again, the probability of failure would be 1 minus 0.90, so it leaves me with 0.10. Okay, and that gives me a standard deviation of about 5.2. And so we'll insert that here. So the mean minus 2 times the standard deviation. Let's see, it gives me 270 minus, I think 2 times 5.2 will be 10.4. And so anything that's less than this value, which is 259.6, anything less than this would be considered significantly low. So since 240 is definitely less than that, 240 is considered significantly low. So, excuse me. So since 240 is significantly low, we might try and come up with reasons why, and it really depends on the sample that we took. Maybe there was some bias in our sample. For some reason, we got an unusually low number of participants who started smoking before 18. So we can look at our sample and say, okay, well, maybe there were a disproportionate number of women versus men, or maybe there were a disproportionate number of educated versus non-educated people, or maybe the age had something to do with it. So there, you can look at the sample and try and see if there was any sort of bias in our sample that might give us this unusually low number of smokers who started before the age of 18. All right, and we'll leave it there for chapter 5.